So hello everyone, welcome back to my channel. My name is Antonio G. Tolosa. So for this day we will summarize the chapter 7 of networking 1 in NetACAT. But before that, we need to read the introduction of this chapter. Okay. So chapter 7, IP addressing. So addressing is a critical function of a network layer protocol. Addressing enable data communication between hosts regardless of whether the hosts are on the same network or on different network. So both Internet Protocol version 4, IP version 4, and Internet Protocol version 6 provide hierarchical addressing for packets that carry data. Designing, implementing, and managing an effective IP addressing plan ensure that network can operate effectively and efficiently. So this chapter examines in details the structure of IP addressing and their application to the construction and testing of the IP network and subnetwork. So we are done in reading this introduction. So we need to go to the chapter 7 summary and conclusion. So IP addresses. So IP addresses are hierarchical with network, subnetwork, and host version. The IP address can represent a complete network, a specific host, or a broadcast address of the network. So understanding binary notation is important when determining if two hosts are in the same network. The bits within the network portion of the IP address must be identical for all devices that reside in the same network. So, the subnet mask of a prefix is used to determine the network portion of an IP addresses. IP addresses can be assigned either statically or dynamically. DHCP enable the automatic assignment of the addressing information such as IP address, subnet mask, default gateway, and other configuration information. So, IP version 4 hosts can communicate one of three different ways: the unicast, the broadcast, or multicast. So, also block of addresses that are used in network that requires limited or no internet access are called private addresses. So, the private IP version 4 address block are 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16. So the depletion of IP version 4 address space is the motivating factor for moving to IP version 6. So each IP version 6 address has 128 bits versus the 32 bits in an IP version 4 address. So IP version 6 does not use the data decimal subnet mask notation. The prefix length is used to indicate the network portion of an IP version 6 address using the following format: IP version 6 address prefix notation, prefix length rather. So there are three types of IP version 6 addresses: the unicast, the multicast, and the anycast. So, an IP version 6 link local address enable a device to communicate with other IP version 6 enable device on the same link and only on the link subnet. So, packet with its source or destination link local address cannot be routed beyond the link from which the packet originated. So IP version 6 link local addresses are in the FE80/10 range. So ICMP is available for both IP version 6 and IP version 4. I ICMP version 4 is the messaging protocol for IP version 4, and the ICMP version 6 provides the same services for IP version 6 but includes additional functionality. So after it is implemented, an IP network needs to be tested to be verify its connectivity and operational performance. So this chapter, which is the chapter 7, is all about the logical and. So it is one of the three basic binary operation used in digital logic, and the other two are the OR and NOT. Also, this chapter discuss the three ways to communicate to other devices: the unicast, the broadcast, and the multicast. So the unicast is a process of sending a packet from one host to another to individual hosts. Next is the broadcast. So it is a process of sending a packet from one host to all hosts in the network. Then the last is the multicast. So it is process of sending a packet from one host to a selected group of hosts, possibly in different network. Also in this chapter, also in this chapter, so it tells about the conversion of the binary to decimal. So I will show you a video that will show you, give you an explanation for on how to convert a binary to the decimal. Think.
Hello, and this is Sunny. Welcome back. Today my topic is how to convert binary numbers to decimal numbers in terms of IP version 4 address. IP address is a 32-bit long value. Now let's look at this IP address in binary format. It is a 32-bit long string of zeros and ones. There's 4 sets or 4 groups of zeros and ones separated by dot. Each set is 8-bit long, and that's why we call it an octet. Now let's convert this IP address from binary numbers to decimal numbers. First, let's draw a 2-row, 8-column table. Starting from the right side, filling in the top row with 8 numbers: 1, 2, 4, 8, 16, 32, 64, 128. There's a pattern for these 8 numbers. Starting with 1, next number is 2, which is double 1. 4 is double 2. 8 is double 4, and 16 is double 8, and 32 is double 16, and 64 is double 32, and 128 is double 64. Let's call this table the binary table, because we will use this table in the following several videos. It's very useful table. Let's convert these first 8-bit binary numbers, or the first octet. This is how it works. We put 8 binary numbers to the binary table from left to right, one by one, making sure these 8 binary numbers match their positions in the table. Now we look at ones only, ignoring zeros. There's 4 ones. In the second row, there's 4 ones. The next step is bring down the numbers above the 1. They are 128, 32, 4, and 1. Then we add them up. 128 plus 32 plus 4 plus 1, we got 165. That's it. The first octet is 165 in decimal value. Let's convert the second octet, the second group. We put 8 binary numbers to the binary table one by one. We look at the ones only, ignoring zeros. We bring down the numbers above the ones, which are 32, 16, 8, and 2. We add them up and we got 58. Thus, the second octet is 58 in decimal value. Let's do the third octet. We repeat the same process by putting the 8 binary numbers to the binary table one by one. We only look at the ones and bring down the numbers matching ones. We add them up and we got 199. That's the third octet in decimal value. Now let's finish the fourth octet. We repeated the same process. We only look at the ones, ignore all zeros, and bring down the numbers above ones, which are 32, 8, 2, and 1. Adding them up, we got 43. Thus, this IP address in ones and zeros is converted into IP address with a more human-friendly format, decimal values, which is 165.58.199.43. I hope this video is helpful, and thank you very much, and see you next time.
So that's all for today, and see you in my next video. Bye bye.